January 31, 1863. Charleston Harbor, South Carolina. In the pre-dawn darkness, two Confederate ironclad warships slipped silently across the harbor bar like steel ghosts emerging from the mist. The CSS Palmetto State and CSS Chicora were about to attempt something that had never been tried before in naval warfare. Confederate ironclads would venture into open ocean to break a Union naval blockade using an unauthorized weapon design that defied every conventional naval engineering principle of the era. What made this moment revolutionary was not just the audacity of the attack, but the fact that these vessels existed at all. They were built from blueprints that had been rejected by Confederate naval authorities, designed by an engineer whose unauthorized modifications violated official construction standards, and funded through desperate local initiatives when the central government refused to support the project. The man responsible for this engineering rebellion was John Luke Porter, chief naval constructor of the Confederate States Navy, whose unapproved design innovations would break the Union blockade overnight and change naval warfare forever. Porter's story begins not with military ambition, but with institutional frustration and bureaucratic blindness that refused to acknowledge the realities of modern naval combat. When the Civil War erupted in 1861, naval warfare was transforming from wooden ships firing solid shot to ironclad vessels mounting explosive shells. Yet military establishments on both sides remained trapped in outdated thinking that emphasized traditional ship design over revolutionary engineering solutions. Born in Portsmouth, Virginia, on September 13, 1813, John Luke Porter learned shipbuilding from his father in the cradle of American naval construction. His early career with the United States Navy exposed him to the limitations of wooden warships and the emerging potential of iron armor, but his innovative ideas were consistently dismissed by conservative naval bureaucrats who preferred proven designs over experimental concepts that challenged established doctrine. In 1846, Porter submitted plans for an ironclad warship to the U.S. Navy Department, proposing a revolutionary design that incorporated sloped iron armor over a conventional hull to deflect enemy fire while maintaining seaworthiness. The proposal was rejected without serious consideration because American naval authorities insisted that wooden ships of the line remained the ultimate expression of naval power, despite mounting evidence from European conflicts that explosive shells could destroy wooden vessels with devastating effectiveness. Porter's prescient understanding of naval warfare's future direction reflected his systematic analysis of combat reports from the Crimean War, where French and British ironclad floating batteries had proved nearly invulnerable to Russian shore artillery. His technical analysis demonstrated that iron armor could neutralize the advantage of explosive shells, but American naval leadership remained committed to traditional wooden construction that emphasized speed and maneuverability over protection and survivability. When Virginia seceded from the Union in April 1861, Porter faced a momentous decision that would define his career and influence the development of ironclad warfare throughout the world. Despite opposing both secession and slavery, Porter chose loyalty to his native state over allegiance to the federal government, bringing his revolutionary naval engineering expertise to the Confederate cause at the moment when innovative thinking could provide maximum strategic advantage. Porter's decision to join the Confederate Navy occurred at the precise moment when traditional naval thinking was colliding with technological reality. The Union naval blockade threatened to strangle Confederate commerce and military logistics, while conventional wooden warships proved increasingly vulnerable to modern artillery that could penetrate hulls and detonate magazines with catastrophic results. The Confederacy desperately needed innovative naval solutions, but institutional conservatism initially prevented adoption of Porter's revolutionary design concepts. The conversion of USS Merrimack into CSS Virginia provided Porter with his first opportunity to demonstrate ironclad principles under combat conditions. Working with Lieutenant John Mercer Brooke and engineer William Williamson, Porter supervised the transformation of a scuttled wooden frigate into an ironclad casemate vessel that incorporated his theoretical armor concepts into practical reality. The resulting warship would prove ironclad superiority over wooden vessels in the most decisive naval engagement of the 19th century. CSS Virginia's performance during the Battle of Hampton Roads on March 8 and 9, 1862, validated every aspect of Porter's ironclad theory while demonstrating the obsolescence of wooden naval architecture. Virginia's sloped iron casemate deflected shot from the most powerful Union naval guns, while her own artillery destroyed two major wooden warships and forced the entire Union fleet to withdraw from combat. The engagement proved that properly designed ironclads were virtually invulnerable to conventional naval artillery. However, Virginia's success also revealed fundamental limitations in Porter's initial design approach that would require significant modifications for future ironclad construction. Virginia's deep draft prevented operations in shallow coastal waters. Her underpowered engines limited strategic mobility, and her long construction time made rapid warship production impossible under wartime conditions. Porter recognized that ironclad effectiveness required design innovations that balanced protection, performance, and production efficiency. Porter's analysis of Virginia's operational limitations led to development of the Richmond-class ironclad design that would revolutionize Confederate naval construction through innovative engineering solutions that maximized combat effectiveness while minimizing resource requirements. The Richmond class incorporated lessons learned from Virginia's combat experience while addressing specific tactical requirements of harbor defense and blockade running that differed fundamentally from open ocean naval warfare. The Richmond class design represented Porter's attempt to create a standardized ironclad configuration that could be constructed efficiently at multiple shipyards using locally available materials and manufacturing capabilities. The design featured a 150-foot hull with a casemate armored with 4 inches of iron over 22 inches of timber, mounting 4 7-inch Brooke rifles that provided effective firepower against wooden vessels while maintaining reasonable construction costs and timeline. Porter's Richmond-class blueprints incorporated several unauthorized modifications that violated official Confederate naval construction standards but reflected his practical understanding of combat requirements and manufacturing limitations. The modifications included simplified hull lines that reduced construction complexity, standardized armor configurations that could utilize available iron supplies efficiently, and modular weapons installations that enabled customization for specific tactical requirements. The unauthorized nature of Porter's design modifications reflected bureaucratic conflicts within Confederate naval administration that prevented rapid adoption of innovative engineering solutions. Navy Secretary Stephen Mallory and other senior officials preferred centralized design control that ensured standardization and quality control, while Porter advocated decentralized innovation that enabled local adaptation to specific operational requirements and resource availability. Porter's conflict with naval bureaucracy intensified when he proposed constructing Richmond-class ironclads at Charleston, South Carolina, to defend the port against Union naval attack and break the increasingly effective blockade that was strangling Confederate commerce. Charleston's strategic importance as a blockade-running port and symbolic significance as the birthplace of secession made its defense a critical Confederate priority, but official naval policy emphasized concentration of ironclad construction at major shipyards in Virginia and Alabama. The rejection of Porter's Charleston ironclad proposal by Confederate naval authorities reflected institutional thinking that prioritized resource conservation over strategic initiative. Senior officials argued that Charleston lacked adequate shipbuilding facilities and experienced naval constructors, making ironclad construction impossible without massive infrastructure investment that the Confederacy could not afford during wartime conditions. Porter's response to bureaucratic rejection demonstrated the innovative thinking that characterized his entire career and would ultimately revolutionize Confederate naval capabilities. Rather than accepting official refusal, Porter secretly provided his unauthorized Richmond-class blueprints to Charleston shipbuilders and local officials who recognized the critical importance of ironclad defense for their besieged port city. The unauthorized transfer of Porter's blueprints to Charleston initiated a remarkable example of local initiative overcoming institutional inertia to achieve strategic objectives that central authorities had deemed impossible. Charleston's civic leaders, recognizing that their survival depended on effective naval defense, organized funding campaigns and resource mobilization efforts that enabled ironclad construction without official Confederate government support. The construction of CSS Palmetto State began in January 1862, under the supervision of Cameron and Company, Charleston shipbuilders who had never constructed ironclad vessels, but possessed the determination and ingenuity necessary to transform Porter's revolutionary blueprints into combat-ready warships. The project represented an extraordinary example of civilian initiative, achieving military objectives through innovative engineering and community cooperation. Palmetto State's construction faced enormous challenges that would have defeated less determined builders, including shortages of iron armor, lack of suitable engines, and absence of experienced ironclad construction workers. However, Charleston's shipbuilders demonstrated remarkable resourcefulness in adapting Porter's designs to local conditions while maintaining the essential characteristics that would ensure combat effectiveness against Union naval forces. The funding for Palmetto State's construction came from a patriotic appeal in Charleston newspapers that called upon the women of Charleston to raise money for gunboat construction through private subscription. The response exceeded all expectations, demonstrating community commitment to naval defense that enabled completion of the ironclad, despite lack of official government support for the unauthorized project. Construction of CSS Chicora began simultaneously under the supervision of James Eason's Charleston shipyard, creating the first time that Confederate ironclads had been built concurrently at the same location using identical design specifications. The parallel construction enabled efficiency improvements and quality control measures that would not have been possible with single-vessel projects, while providing Charleston with two ironclads that could operate cooperatively against Union naval forces. Porter's involvement in the Charleston ironclad project remained unofficial throughout the construction process, reflecting his precarious position within Confederate naval administration, where his innovative thinking was valued, but his unauthorized initiatives created political complications. Porter provided technical guidance and design modifications through informal channels while maintaining plausible deniability regarding his violation of official construction policies. The technical challenges of constructing ironclads in Charleston using Porter's unauthorized blueprints required constant innovation and adaptation that tested the limits of Confederate engineering capabilities. Charleston's shipbuilders lacked access to the specialized tools and materials available at major naval shipyards, forcing them to develop improvised solutions that often proved superior to conventional construction methods. The armor for both Charleston ironclads presented particularly complex challenges because the vessels required iron plates that exceeded local manufacturing capabilities. Charleston's builders solved this problem through innovative procurement strategies that acquired iron from multiple sources, including railroad rails, demolished buildings, and captured Union materials, demonstrating the resourcefulness that characterized Confederate engineering throughout the war. The engines for Palmetto State and Chicora represented another major challenge because Charleston lacked the heavy industrial capacity to manufacture marine propulsion systems suitable for ironclad vessels. Both ships ultimately received underpowered engines salvaged from civilian steamers, limiting their speed and maneuverability, but providing adequate propulsion for harbor defense and blockade-breaking operations. Porter's weapons specifications for the Charleston ironclads emphasized the Revolutionary Brooke rifles developed by Lieutenant John Mercer Brooke, which provided superior penetrating power against enemy armor while utilizing Confederate manufacturing capabilities efficiently. The guns represented cutting-edge artillery technology that gave Confederate ironclads significant advantages over Union vessels, mounting conventional naval artillery. The completion of both Charleston ironclads in late 1862 provided the Confederacy with unprecedented naval capabilities at the critical port that served as the primary entry point for blockade runners carrying essential supplies from Europe. The vessels represented Porter's unauthorized engineering triumph and demonstrated that innovative design concepts could overcome resource limitations through determination and creative problem-solving. CSS Palmetto State measured 150 feet in length with a beam of 35 feet and displaced approximately 1,400 tons, mounting four 7-inch Brook rifles in a casemate protected by 4 inches of iron armor over 22 inches of timber backing. The vessel's low freeboard and sloped armor configuration deflected enemy fire while presenting a minimal target profile that enhanced survivability in combat. CSS Chicora incorporated similar design characteristics while being slightly larger at 152 feet in length, with enhanced armor protection and upgraded weapons systems. Both vessels represented successful implementation of Porter's unauthorized design concepts while demonstrating the effectiveness of decentralized ironclad construction using innovative engineering solutions adapted to local conditions. The strategic significance of the Charleston ironclads extended far beyond their immediate military capabilities to influence Confederate naval policy and Union blockade strategy throughout the Atlantic coast. The vessels proved that effective ironclad construction was possible at secondary shipyards using unconventional methods, encouraging similar projects at other Confederate ports, while forcing Union commanders to strengthen their blockading squadrons with ironclad vessels. Porter's unauthorized blueprint distribution to Charleston established a precedent for innovative engineering solutions that circumvented bureaucratic obstacles to achieve critical military objectives. His willingness to violate official policies in pursuit of strategic advantage demonstrated the importance of individual initiative when institutional processes failed to address urgent operational requirements. The combat debut of Porter's Charleston ironclads occurred during the pre-dawn hours of January 31, 1863, when both vessels sortied from Charleston Harbor to attack the Union blockading squadron in the first offensive operation by Confederate ironclads in open ocean conditions. The attack represented the ultimate test of Porter's unauthorized design concepts under actual combat conditions against experienced enemy naval forces. Captain John Rutledge commanded CSS Palmetto State during the attack, leading the formation as it approached the Union blockading vessels through thick haze that provided concealment until the ironclads achieved optimal firing positions. The element of surprise enabled the Confederate vessels to engage enemy ships at close range before Union commanders could organize effective defensive responses. CSS Chicora, commanded by Captain John Tucker, followed Palmetto State into action and engaged Union vessels with devastating effectiveness that demonstrated the superiority of ironclad design over wooden warship construction. The Confederate attack achieved complete tactical surprise and inflicted significant damage on Union vessels while suffering minimal casualties in return. The first target of the Confederate attack was USS Mercedita, a wooden sidewheel gunboat that represented typical Union blockading vessels designed for speed and long-range patrol duties rather than combat against armored opponents. Palmetto State's ramming attack and point-blank artillery fire disabled Mercedita's propulsion system and forced her surrender within minutes of the engagement's beginning. USS Keystone State became the second victim of the Confederate ironclad attack when Chicora's 7-inch Brook rifles penetrated her wooden hull and ruptured steam lines, causing massive casualties and forcing her temporary surrender. The engagement demonstrated the devastating effectiveness of Confederate ironclad artillery against conventional wooden warships that lacked adequate protection against modern naval guns. The Confederate attack created panic throughout the Union blockading squadron as wooden vessels attempted to escape from ironclad opponents whose armor deflected return fire while their artillery systematically destroyed enemy ships. The engagement proved that properly designed ironclads could neutralize numerically superior conventional naval forces through technological advantages that conventional tactics could not overcome. General Pierre-Gustave Toutant-Beauregard, commanding Confederate forces at Charleston, immediately recognized the strategic significance of the ironclad attack and declared that the Union blockade had been officially broken according to international maritime law. Beauregard's proclamation claimed that the Confederate naval success had lifted the blockade and opened Charleston Harbor to neutral shipping, potentially providing international recognition of Confederate sovereignty. The legal implications of Beauregard's blockade-breaking proclamation created international diplomatic complications that extended far beyond the immediate military situation. Under established maritime law, a naval blockade that was successfully challenged by enemy forces became invalid and required complete re-establishment before international recognition could be restored, potentially creating weeks of opportunity for Confederate commerce. However, Union naval commanders refused to acknowledge the blockade's disruption and maintained that scattered vessels had regrouped quickly enough to preserve legal continuity of the blockading operation. The dispute over blockade legitimacy reflected broader questions about Confederate sovereignty and international recognition that influenced European diplomatic policy throughout the war. The immediate tactical success of Porter's Charleston ironclads extended beyond their specific combat achievements to demonstrate strategic principles that would influence naval warfare development throughout the world. The engagement proved that innovative engineering could overcome resource limitations and technological disadvantages through creative design solutions that maximized available capabilities. Porter's unauthorized blueprint modifications had enabled construction of effective ironclad vessels using materials and methods that conventional naval authorities considered inadequate for warship construction. The success validated his engineering philosophy that emphasized practical effectiveness over bureaucratic compliance when critical military objectives required innovative solutions. The Charleston ironclad attack influenced Union naval strategy by forcing deployment of Monitor-class ironclads to strengthen blockading squadrons throughout the Confederate coast. The requirement for ironclad countermeasures diverted Union naval resources from offensive operations while demonstrating that Confederate engineering innovation could achieve strategic effects despite material disadvantages. Admiral Samuel DuPont, commanding Union naval forces in the South Atlantic, recognized that the Confederate ironclad threat required fundamental changes in blockading strategy and tactics. DuPont's subsequent preparations for attacking Charleston Harbor, with a squadron of Union Monitor ironclads, reflected acknowledgement that wooden vessels could no longer operate effectively in waters defended by enemy ironclads. The April 7, 1863, Union ironclad attack on Charleston Harbor represented the direct consequence of Porter's unauthorized engineering success, as DuPont assembled the largest concentration of Monitor-class ironclads ever deployed in a single operation. The Union attack involved 9 ironclad vessels, including 7 Passaic-class monitors, designed specifically to counter Confederate ironclad threats. Porter's Charleston ironclads played a crucial defensive role during the Union attack, remaining in reserve behind Fort Sumter, while Confederate shore batteries engaged the attacking monitors. The presence of Confederate ironclads forced Union commanders to consider the possibility of combined fort and ship attacks that could have devastated the Union squadron if the forts had been successfully reduced. The failure of the Union ironclad attack validated Porter's defensive strategy and demonstrated that properly positioned shore fortifications could defeat even the most powerful naval forces when supported by ironclad vessels held in reserve. The engagement established principles of combined arms defense that would influence coastal fortification strategy throughout the world. The strategic consequences of Porter's unauthorized ironclad success extended throughout Confederate naval operations, as other ports requested similar vessels for blockade defense and commerce protection. The Charleston example demonstrated that effective ironclad construction was possible at secondary shipyards when innovative engineering overcome resource limitations through creative problem-solving. Porter's subsequent ironclad designs incorporated lessons learned from Charleston operations while addressing specific requirements of different ports and tactical situations. His standardized blueprints enabled efficient construction of similar vessels at multiple locations, while allowing modifications that adapted basic designs to local conditions and available materials. The Richmond-class ironclad design became the foundation for Confederate naval construction throughout the war, with variations built at shipyards from Virginia to Texas, using Porter's basic engineering concepts adapted to specific requirements. The design's flexibility and effectiveness validated Porter's approach of standardized innovation that combined proven principles with local adaptation. CSS Charleston and CSS Columbia represented the next generation of Porter's ironclad development, incorporating improvements based on combat experience while maintaining the essential characteristics that had made the original Charleston ironclads so effective. Both vessels featured enhanced armor protection and upgraded weapon systems that reflected Porter's continuous innovation in ironclad design. The construction of additional Charleston ironclads demonstrated the sustainability of Porter's unauthorized engineering approach and proved that innovative design concepts could support ongoing warship production despite resource limitations. The success encouraged similar projects at other Confederate ports while establishing Charleston as a major center of ironclad construction. Porter's role as chief naval constructor enabled him to formally incorporate successful unauthorized innovations into official Confederate naval policy, legitimizing design concepts that had proved effective under combat conditions. His position provided institutional authority to promote innovative engineering solutions that had initially been rejected by conservative naval bureaucracy. The technical documentation of Porter's ironclad designs influenced naval engineering education and warship development long after the Civil War's conclusion. His emphasis on practical effectiveness over theoretical perfection established design principles that continued to guide naval architecture throughout the transition from ironclad to modern steel warship construction. The international recognition of Porter's engineering achievements influenced naval development in European countries that studied Confederate ironclad innovations for application to their own naval construction programs. The effectiveness of Porter's designs under combat conditions validated engineering principles that transcended national boundaries and technological limitations. Modern naval architects recognize Porter's ironclad innovations as fundamental contributions to warship design that established principles still evident in contemporary naval construction. His emphasis on protection, firepower, and production efficiency created design philosophies that continue to influence naval engineering throughout the world. Porter's willingness to circumvent bureaucratic obstacles through unauthorized innovation demonstrated the importance of individual initiative when institutional processes failed to address critical operational requirements. His example influenced military engineering culture regarding the balance between regulatory compliance and mission effectiveness during emergency conditions. The broader implications of Porter's unauthorized blueprint distribution extended beyond immediate military applications to influence industrial development and technological innovation throughout the Confederacy. His demonstration that effective warship construction was possible using unconventional methods encouraged similar innovations in other military and civilian applications. The Charleston Ironclad Project established precedents for public-private cooperation in military procurement that influenced Confederate industrial policy throughout the war. The success of civilian funding and construction efforts demonstrated that community initiative could achieve strategic objectives when central government resources proved inadequate. Porter's engineering philosophy emphasized practical problem-solving over theoretical perfection, creating design approaches that maximized effectiveness within resource constraints while maintaining essential operational capabilities. His methods provided templates for technological innovation under adverse conditions that influenced engineering practice far beyond naval applications. The legacy of Porter's unauthorized ironclad innovations extends to contemporary military engineering and defense acquisition procedures that emphasize rapid prototyping and field testing over lengthy bureaucratic approval processes. His example demonstrates that revolutionary technologies often emerge from individual initiative rather than institutional programs. Porter's post-war career included management positions with civilian shipbuilding companies that utilized his ironclad engineering experience for commercial vessel construction. His transition from military to civilian applications demonstrated the broader utility of innovative engineering principles that transcended specific technological applications. The preservation of Porter's technical drawings and construction documentation provides contemporary naval historians with detailed insight into Civil War ironclad design and construction methods. His systematic approach to engineering documentation established standards for technical record-keeping that influenced naval architecture education and practice. Educational institutions throughout the world study Porter's ironclad innovations as examples of successful engineering innovation under resource constraints and institutional opposition. His methods provide case studies in technological development that emphasize creativity and determination over conventional approaches to complex problems. The January 31, 1863 attack by Porter's Charleston ironclads represented more than successful naval combat. It demonstrated that individual engineering innovation could overcome institutional obstacles to achieve strategic objectives that conventional thinking deemed impossible. Porter's unauthorized blueprint modifications had created ironclad vessels that broke the Union naval blockade overnight and changed the course of naval warfare. Porter's engineering rebellion proved that revolutionary technologies often emerge from individual initiative rather than institutional programs, requiring courage to challenge conventional wisdom when established procedures failed to address critical operational requirements. His willingness to violate bureaucratic policies in pursuit of strategic advantage established precedents for innovation that continue to influence military engineering. The two ironclad vessels that Porter's unauthorized blueprints had created slipped back into Charleston Harbor after their successful attack, having achieved what Confederate naval authorities had declared impossible. The Union blockade had been broken, international maritime law had been satisfied, and the world had witnessed the emergence of a new era in naval warfare, created by one engineer's refusal to accept institutional limitations. That's how John Luke Porter's unauthorized weapon blueprint ended a naval blockade overnight and established engineering principles that revolutionized warship design throughout the world. His defiant innovation proved that individual creativity could overcome institutional obstacles when critical objectives required revolutionary solutions rather than conventional approaches to complex military problems. The technical specifications of Porter's Richmond-class ironclad design reflected years of systematic analysis of naval combat requirements and manufacturing limitations that conventional naval architects had failed to address adequately. Porter's blueprints specified precise armor configurations, weapons installations, and hull dimensions that maximized combat effectiveness while minimizing resource requirements and construction complexity. The armor system that Porter designed for his Charleston ironclads incorporated lessons learned from CSS Virginia's combat experience while addressing specific tactical requirements of harbor defense operations. The 4-inch iron plates were backed by 22 inches of timber and angled at 40 degrees to deflect enemy projectiles, creating protection that could withstand the heaviest Union naval artillery while maintaining reasonable weight and construction costs. Porter's weapons configuration emphasized the revolutionary Brooke rifles that provided superior penetrating power against enemy armor, while utilizing Confederate manufacturing capabilities efficiently. The 7-inch rifles mounted in each ironclad could penetrate Union monitor armor at combat ranges while the vessel's own armor deflected return fire, creating significant tactical advantages for Confederate naval forces. The propulsion systems specified in Porter's blueprints reflected practical compromises between optimal performance and available manufacturing capabilities. While Porter preferred powerful marine engines specifically designed for ironclad operations, the Charleston vessels received underpowered civilian steamer engines that limited speed and maneuverability, but provided adequate propulsion for their intended missions. Porter's hull design incorporated innovative features that enhanced seaworthiness while maintaining the low profile essential for effective armor protection. The vessels featured traditional ship-type hulls, with flat casemate ends that provided structural strength and manufacturing simplicity, while ensuring adequate stability and handling characteristics in harbor and coastal operations. The construction techniques specified in Porter's unauthorized blueprints enabled efficient ironclad construction using traditional shipbuilding methods adapted for armored vessel requirements. The designs emphasized modular construction that allowed parallel work on different vessel components, while maintaining quality control and enabling modifications during the construction process. Porter's engineering philosophy emphasized practical effectiveness over theoretical perfection, creating design approaches that maximized operational capabilities within resource constraints, while maintaining essential combat characteristics. His methods provided templates for technological innovation under adverse conditions that influenced engineering practice throughout the Confederate war effort. The strategic implications of Porter's unauthorized ironclad program extended far beyond the immediate tactical success of the Charleston attack to influence Confederate naval policy and Union blockade strategy throughout the war. The demonstration that effective ironclads could be constructed at secondary shipyards encouraged similar projects while forcing Union commanders to strengthen their blockading squadrons with armored vessels. The procurement methods that Porter pioneered for the Charleston Ironclad project established precedents for public-private cooperation in military acquisition that influenced Confederate industrial policy throughout the conflict. The success of civilian funding and construction efforts demonstrated that community initiative could achieve strategic objectives when central government resources proved inadequate for critical military requirements. Porter's systematic documentation of ironclad construction methods and performance characteristics created technical databases that influenced naval engineering education and warship development for decades beyond the Civil War's conclusion. His emphasis on detailed record-keeping established standards for engineering documentation that continued to guide naval architecture practice throughout the transition from ironclad to modern steel warship construction. The international recognition of Porter's engineering innovations influenced naval development in European countries that studied Confederate ironclad designs for application to their own naval construction programs. British, French, and Russian naval architects analyzed Porter's armor configurations and weapons installations to develop improved ironclad designs that incorporated lessons learned from American combat experience. The technological legacy of Porter's unauthorized ironclad innovations extended throughout modern naval engineering to influence contemporary warship design principles that emphasize protection, firepower, and production efficiency. His engineering philosophy established design approaches that continue to guide naval architecture in addressing complex tactical requirements within resource and manufacturing constraints. Porter's role in Confederate naval administration evolved significantly following the success of his Charleston Ironclad project, as senior officials recognized the value of his innovative engineering approaches and systematic problem-solving methods. His promotion to Chief Naval Constructor provided institutional authority to incorporate successful unauthorized innovations into official Confederate naval policy. The formal adoption of Porter's design principles by Confederate naval authorities legitimized engineering concepts that had initially been rejected by conservative bureaucracy, demonstrating that innovative solutions could achieve institutional acceptance through demonstrated effectiveness under operational conditions. The policy changes encouraged similar innovations throughout Confederate military engineering organizations. Porter's subsequent ironclad designs incorporated continuous improvements based on combat experience and technological developments, while maintaining the essential characteristics that had made his original innovations so effective. His standardized design approach enabled efficient construction of similar vessels at multiple locations, while allowing modifications that adapted basic concepts to specific tactical requirements and available materials. The construction of CSS Charleston represented the next evolution of Porter's ironclad development, incorporating enhanced armor protection and upgraded weapons systems while maintaining the production efficiency that had made the original Charleston ironclads so successful. The vessel featured 6 inches of iron armor over 24 inches of timber backing, providing superior protection against the increasingly powerful Union naval artillery. CSS Columbia represented Porter's most ambitious ironclad design, featuring a length of 213 feet and displacement of over 2,000 tons, with armor protection that exceeded any previous Confederate vessel. The ship mounted 8 heavy Brooke rifles and incorporated advanced engineering features that reflected Porter's continuous innovation in ironclad technology. The engineering challenges of constructing larger and more complex ironclads tested the limits of Confederate manufacturing capabilities while demonstrating the scalability of Porter's design principles. The successful completion of these advanced vessels validated his systematic approach to naval engineering and proved that innovative design concepts could support increasingly sophisticated naval construction programs. Porter's influence on Confederate naval construction extended throughout shipyards from Virginia to Texas, as his standardized design principles enabled efficient ironclad construction at facilities that lacked experience in armored vessel building. The widespread adoption of his engineering methods demonstrated the effectiveness of systematic innovation in overcoming resource limitations and technical challenges. The tactical employment of Porter's ironclads evolved throughout the war, as Confederate naval commanders developed innovative strategies that maximized the vessel's capabilities while addressing their operational limitations. The ironclads served effectively as harbor defense vessels, commerce raiders, and blockade breakers, while influencing Union naval strategy and resource allocation throughout the conflict. The defensive capabilities of Porter's ironclads proved particularly effective when combined with shore fortifications and underwater obstacles that created integrated defense systems capable of defeating even the most powerful Union naval attacks. The successful defense of Charleston Harbor against Admiral DuPont's ironclad squadron demonstrated the effectiveness of combined arms operations that utilized both land and naval forces. The psychological impact of Porter's ironclad innovations extended throughout Union naval forces, as commanders recognized that wooden vessels could no longer operate effectively in waters defended by Confederate armored ships. The requirement for ironclad countermeasures diverted Union naval resources from offensive operations while validating Confederate engineering capabilities. The industrial implications of Porter's ironclad program influenced Confederate manufacturing policy, as government officials recognized the importance of supporting innovative engineering projects that could achieve strategic objectives despite material disadvantages. The success of the Charleston project encouraged investment in naval construction facilities and technical education programs throughout the Confederacy. Porter's training and education programs for Confederate naval constructors established systematic approaches to ironclad engineering that ensured consistent quality and performance standards across multiple shipyards. His emphasis on technical education and systematic problem-solving methods influenced Confederate engineering practice throughout the war, while establishing foundations for post-war industrial development. The economic impact of Porter's ironclad innovations extended beyond immediate military applications to influence Confederate industrial development and technological capabilities. The engineering methods and manufacturing techniques developed for ironclad construction found applications in civilian industries while demonstrating the potential for technological innovation under resource constraints. Porter's post-war career reflected the broader applications of his engineering expertise, as he transitioned from military to civilian shipbuilding while maintaining his commitment to innovative design solutions and systematic problem-solving methods. His involvement in commercial vessel construction demonstrated the peacetime utility of wartime engineering innovations. The Norfolk and Portsmouth ferry system that Porter managed during his later career utilized engineering principles developed during his ironclad construction experience, while providing essential transportation services for the regional economy. His civilian applications of military engineering expertise demonstrated the broader value of innovative problem-solving methods. The preservation efforts that maintain Porter's technical drawings and construction documentation provide contemporary researchers with detailed insight into Civil War engineering methods and technological development. The surviving blueprints and specifications continue to influence naval architecture education while offering valuable case studies in innovative engineering under adverse conditions. Modern naval museums throughout the world display exhibits featuring Porter's ironclad innovations and their influence on warship development. The displays emphasize the importance of individual initiative and innovative thinking in achieving technological breakthroughs that transcend immediate military applications to influence broader industrial and scientific development. Educational institutions utilize Porter's engineering methods as examples of successful innovation under resource constraints and institutional opposition. His systematic approach to complex technical problems provides templates for contemporary engineering education while demonstrating the importance of practical problem-solving over theoretical perfection. The engineering principles that Porter established through his ironclad innovations continue to influence modern naval architecture and defense acquisition procedures. His emphasis on rapid prototyping, field testing, and continuous improvement established methodologies that remain relevant for contemporary military engineering and technological development programs. Porter's legacy in contemporary military engineering includes the recognition that revolutionary technologies often emerge from individual initiative rather than institutional programs, requiring courage to challenge conventional wisdom when established procedures fail to address critical operational requirements. His example continues to inspire innovative approaches to complex technical challenges. The international influence of Porter's ironclad designs extended throughout global naval development as countries worldwide studied Confederate engineering innovations for application to their own naval construction programs. The technical principles that Porter established influenced warship design throughout the transition from ironclad to modern steel construction, while demonstrating the universal applicability of innovative engineering solutions. The strategic lessons learned from Porter's unauthorized blueprint distribution continue to influence military acquisition policy and engineering management procedures. His demonstration that effective innovation could circumvent bureaucratic obstacles while achieving critical objectives established precedents that remain relevant for contemporary defense acquisition and technology development programs. The cultural impact of Porter's engineering achievements extends beyond technical applications to influence broader understanding of individual creativity and institutional innovation. His story demonstrates that determined individuals can overcome significant obstacles to achieve revolutionary breakthroughs that benefit society while establishing precedents for future technological development. Porter's influence on American naval heritage includes recognition as one of the most innovative engineers in naval history, whose contributions to ironclad development established the United States as a leader in naval technology and engineering education. His achievements continue to inspire contemporary naval architects and marine engineers while demonstrating the importance of creative problem-solving in addressing complex technical challenges. The commemoration of Porter's achievements in naval history museums and educational institutions ensures that future generations understand the importance of innovative engineering and individual initiative in achieving technological breakthroughs. His story provides inspiration for contemporary engineers while demonstrating the lasting impact of determined creativity in overcoming institutional obstacles. The technical analysis of Porter's ironclad designs continues to provide valuable insights for contemporary naval architects studying the evolution of warship design and engineering methodology. His systematic approach to complex technical problems offers templates for modern engineering education while demonstrating the importance of practical effectiveness over theoretical perfection. Porter's contribution to the development of modern naval engineering extends beyond specific technical innovations to include broader principles of systematic problem-solving and innovative design methodology. His engineering philosophy continues to influence contemporary naval architecture while providing guidance for addressing complex technical challenges under resource constraints. The lasting significance of Porter's unauthorized blueprint distribution lies not only in its immediate military success, but in its demonstration that individual creativity and institutional innovation can overcome significant obstacles to achieve revolutionary technological breakthroughs. His legacy continues to inspire engineers and innovators while establishing principles that remain relevant for contemporary technological development and military engineering. John Luke Porter's defiant engineering innovation proved that unauthorized blueprints could break naval blockades overnight, while establishing design principles that revolutionized warship construction throughout the world. His courage in challenging institutional authority when critical objectives required innovative solutions created precedents that continue to influence military engineering and technological development more than 160 years after his Charleston ironclads slipped silently across the harbor bar to change naval warfare forever. The final assessment of Porter's unauthorized blueprint revolution extends beyond immediate military success to encompass broader lessons about innovation, institutional change, and individual determination in achieving technological breakthroughs. His willingness to violate bureaucratic procedures when critical objectives required revolutionary solutions established principles that remain relevant for contemporary engineering and military acquisition programs. The enduring legacy of Porter's Charleston ironclad project demonstrates that effective innovation often requires courage to challenge established authority when conventional approaches prove inadequate for addressing critical operational requirements. His example continues to inspire engineers and military professionals while providing guidance for overcoming institutional obstacles through creative problem-solving and determined initiative.